Simple Rankine cycle works between the pressures 28 bar and 0.06 bar. The initial condition of the steam being dry saturated. Calculate the cycle efficiency, work ratio and specific steam consumption. So first let us draw this TS diagram. So this is process 1 to 2, process 2 to 3, process 3 to 4 and process 4 is to 1. So process 1 to 2, it is the isentropic compression in the pump. It is in process 1 to 2, some work input is given to the pump in order to pump the water to the boiler, which is received from the condenser. So process 2 is to 3, it is the constant pressure heat addition process in the boiler, and process 3 to 4, it is the isentropic expansion in the turbine, and process 4 is to 1, it is the constant pressure heat rejection in the condenser. So in the problem he has given it is operating between the pressures 28 bar and 0.06 bar. That means at point P3 he has given the pressure is at 28 bar, which is nothing but the boiler pressure. So I can write here P3 is equals to P2 also, because at constant pressure heat is added in the boiler. So P4 I can write in terms of P1 because it is a constant pressure process 4 is to 1 where heat rejection takes place. So I can write this P4 is equals to P1 is equals to PC, which is nothing but the condenser pressure. He has given 0.06 bar. In this problem it is asked to calculate the cycle efficiency. So how will calculate the cycle efficiency? Net work done divided by heat supplied. So net work done, how will you calculate? Work done by the turbine minus work done by the pump divided by heat supplied. So second, it is asked to calculate work ratio. Work ratio is calculated by the formula net work done divided by work turbine. And third one is the specific steam consumption. So which is given by the formula 3600 divided by net work done. So net work done, already we know that the work done by the turbine minus work done by the pump. So now let us calculate first one, that is work done by the turbine. So work done by the turbine is given by the formula H3 minus H4. So this H3, so at point 3 the steam is entering the turbine, which is nothing but the saturated vapor. So H3 means enthalpy at point 3 is nothing but 2802. This value is taken from the steam table book at 28 bar. So minus H4. So H4 is the steam exhaust from the turbine. The steam exhaust from the turbine, it will be in the form of wet steam. So this H4 enthalpy at point 4 is calculated by the formula HF4 plus X4 into HFG4. So this X4 indicates the dryness fraction of the steam. So HF4 means enthalpy of the water at point 4. So this is taken from the steam table at pressure 0.06 bar, because already it is given in the problem, plus X4. So HFG4 is also taken from the steam table book at the pressure 0.06 bar. So we don't know this X4. So in order to calculate this X4, we know that the entropy is constant as per the TS diagram. So this is the isentropic expansion of the steam in the turbine. So where entropy is constant at point 3 and point 4. So I can write this S3 is equals to S4. So this S3, that is entropy at point 3, this value is also taken from the steam table book at pressure 28 pressure bar. So this S4 is given by the again formula SF4 plus X4 into SFG4. So SF4 is also taken from the steam table book, that is at 0.06 bar. So SF4 means entropy of water is 0.521 plus X4 only I have to calculate here, that is nothing but the wet steam at zero point 0.4 how much it is wet steam. So SFG4 is also we have taken it from the steam table book at pressure 0.06 bar. So by solving this equation I have got X4 as 0.728. So this X4 value which I have got it as 0.728. So this value I will substitute here. H4 is equals to HF4 plus X4 into HFG4. So if I will solve this H4 I have got it as 1911.68 kilojoules per kg. So this H4 value I have substituted here. So work done by the turbine I have got it as 890.31 kilojoules per kg. So now let us calculate the work input to the pump. So how to calculate this work input to the pump? So this is calculated by using the formula, that is work input to the pump is given by the formula H2 minus H1. So as it is a constant pressure process, P4 is equals to P1 I can write. So therefore whatever the pressure at 0.06 bar we are taking, the same values we can copy it for 0.1 also. So therefore H2 minus H1 is the formula, or in the same way this work input to the pump is also calculated by using the formula Vf into Pb minus Pc. This Pb is nothing but boiler pressure minus condenser pressure. Vf is the volume of the water at 0.1, because this is the work input to volume of water entering into the pump. So this Vf value we have taken it from the steam table only, again at 0.06 bar, which is 0.001. This Pb is 28 bar he has given. Pc condenser pressure is 0.06 into 10 to the power 2, because we have converted this bar into kilopascal. So by solving this we have got work input to the pump is given by this 2.794 kilojoules per kg. So now our next step is to calculate net work done, which is given by the formula work done by the turbine minus work done by the pump. So net work done is given by work done by the turbine minus work done by the pump. So net work done is 887.516 kilojoules per kg. So now our next step is to calculate the heat supplied. So heat supplied is given by the formula H3 minus H2. So H3 already we have calculated, that is enthalpy of steam at 0.3 already we have taken it. So now H2 I don't know, so let us calculate this H2. So already work done by the pump is nothing but H2 minus H1. So H2 minus H1, which is nothing but the work done by the pump, we have calculated this value. This is 2.794. So therefore H2 is equals to H1 plus this value. So H1 is nothing but enthalpy of water at 0.1, which is the same value at HF4. So therefore H2 is equals to 151.53 plus 2.794 is equals to 154.32 kilojoules per kg. So our next step is to calculate the cycle efficiency. So this is the efficiency to calculate the cycle efficiency. Formula is net work done divided by heat supplied. So already we have calculated net work done as 887.516, heat supplied is 264.67. so our value is 0.3352. so efficiency is nothing but, in the percentage if you write, this is 33.52. so work ratio is given by the formula net work done divided by work done by the turbine. So work done by the turbine is 890.31. so this will be the work ratio will be 0.9968. so last one, this is the specific steam consumption. So formula is 3600 divided by 887.516. so this value we have got 4.056, which is nothing but a kilojoules. So this is kilojoules per kilowatt hour. This is our final answer.